Hi everyone, I'm Julia Hyder, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by MachineMetrics. Whether you operate one machine shop or a large multi-factory organization, you likely have a management system such as an ERP or MES in place to monitor and manage operational performance. What if you could immediately improve the accuracy and effectiveness of your management system? With MachineMetrics, real-time production data can be sent to key management systems, as well as function-specific software solutions like CMMs and quoting solutions, making manual data collection and paper-based tracking systems a thing of the past. With critical shop floor data such as cycle times, downtimes, part counts, machine conditions, and more, your shop floor systems can help you make better decisions while automating other activities. In this webinar, MachineMetrics will discuss the importance of integrating equipment with shop floor systems, as well as quick wins you can pursue to gain efficiency and unlock operational insights. Our presenters are Colin McClarty, Technical Product Manager of Partner Integrations, and John Daly, Senior Account Executive at MachineMetrics. Colin has worked directly with customers to implement integrations as a customer success engineer, and he now helps plan and oversee development for platform and software integrations, including ERP and MES. John's career started in the automotive supply chain, developing plant floor applications and supporting manufacturing operation teams. He worked for 12 years at Plex Systems, leading and architecting complex ERP implementations in the automotive, aerospace, industrial goods, and process manufacturing verticals. After working at Siemens as a solution engineering director, he is now a senior account executive at MachineMetrics. You can submit questions for our presenters at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. I also wanted to let everyone know that this webinar is being recorded, and attendees will receive a link to the recording via email. So with all of that, let's get the presentation started.
All right. Thank you so much, Julia. Appreciate it. Yes, and thanks for that introduction. My name is John Daly. I'm super excited to be here today, and I have my esteemed colleague, Colin McClarty, as well.
Hey, everyone.
And yeah, we think we have some really good content to share with you today. A quick agenda. What we're going to review is first we've done the introductions. Thank you, Julia. We're going to talk about the state of the market. Then we're going to get into a little bit more on machine and data integration. And the last piece is we did save the best for last, in my opinion, and that is really where we're going to talk about specific use cases and examples of connecting different systems and the benefits that you'll realize. And then at the end, make note that we're probably going to have about 15 to 20 minutes to have a Q&A session, so we're going to allocate enough time for that. So let's get going. Let's talk about the state of the market. And this ISA 95 framework is a great place to start to establish a good understanding. And you've probably seen different permutations of this in the past, but this is kind of a nice distilled version of what it's showing. And today what we're going to focus on is that MES and ERP side of the business, but how to unlock that lower level, level 0, 1, and 2 down below here, where events happen in microseconds to minutes. So as you can see, production equipment, facilities, quality, there's, you could have an example of that might be a vibration spike on a machine tool spindle or a stroke of a press. Those are all happening in that, millisecond, microsecond type time frame, all the way to minutes for capturing data also off of let's say sensors or PLCs. And so that section is important for us, and we're going to talk more about how to unlock that today. But our focal point today is talking also about how to bridge that gap into these level 3, where primarily management functions are happening. And that's that envelope that's typically in hours. So what we're talking about there is production runs, maintenance work tickets, and those live typically like in a manufacturing execution system, which you're seeing on the right. The top tier of that is very well known. Most companies and manufacturing companies have an ERP system, an enterprise resource planning system, and that's where the time frames can sometimes, in terms of the events and transactions within there, the envelope is expanded out to perhaps days to months, and that could be new product introductions or programs, financial statements, weekly to monthly, let's say, forecasts. That time frame is obviously quite a bit longer, and we want to be able to influence that with data down here in the lower levels, and I'm being able to unlock that information. So this next slide is kind of jumping towards to some of the unfortunate outcomes of unconnected factory systems. And so what you're seeing is every manufacturing facility has experienced poor work center performance in the past, and it happens now. At this moment, you're going to have poor work center performance as a result of maybe a catastrophic broken down machine. It could be labor, where many manufacturers are struggling with labor not showing up, or they're not skilled to run a machine, or perhaps assign the wrong work. And then also many supply chain issues have challenged many manufacturers recently. And that impact then rolls into basically into events that become that manifest over hours and days. And so operators then can be, not utilized. They can either be idle and not being utilized, and also inventory can be affected adversely. So we're talking about lower inventory turns, and that obviously results in less working capital. Secondary processes can be starved as a result of some of this poor work center performance. And then lastly, if we look at from kind of days to weeks time frame, what we're seeing and what you're seeing and realizing, and what we're hearing from manufacturers is you're missing deliveries. You have to outsource, and then also customer satisfaction can start to fail. So being able to bridge that gap is an important piece of what we want to cover today. So you're not realizing the downstream effects that really impact the business from customer sat and missed deliveries. And so that's kind of where we're going next is you might ask, well, why, let's say, does this happen today? And I'm going to go back to this framework because I think it's helpful to describe that today factory systems are siloed. They can be siloed not only from an ERP to an MES system, but they can be also siloed within an MES system and an ERP. So you may not have a connected maintenance quality system into your MES system, or on the ERP system, you may not have that product management function or part master function that's really connected tightly to that ERP system. And that's all, a big challenge for manufacturers. So what a modern tech stack looks like, if we start from kind of that bottom layer again, that level 0 through 2 layer, that biggest challenge is unlocking, let's say, that manufacturing moment, the moment it happens, down to that, let's say, micro millisecond minute level, and being able to unlock that into other MES systems and ERP systems. And so as we look at that bottom section, PLCs and CNC equipment and sensors and robots, all of that information can be transferred up into a modern, let's say, machine monitoring platform that then can connect and converse with MES systems, which may include a maintenance system and a quality system. Take that data basically and abstract that in a way where it can be digested into that MES or ERP system, super important. So on a plant level, being able to take that abstraction of that data, transfer it to an MES level so it makes sense, so we can have insights, and then even above and beyond that, the plant level, taking that to the enterprise level, and to be able to make those longer term business decisions and be able to realize the impact of that information coming from the plant floor. So the next piece right here is we're going to talk about machine and data integration. And so this particular slide is, shows, some traditional methods of data capture. On the left, human and manual. Everybody's experienced that in the past. What we're seeing though is obviously there's a big shift in between going away from that and more focusing on bridging that operational technology and informational technology gap and autonomously collecting rich information that's coming from CNC and PLC controllers, internal sensors that are within, let's say, a machine tool asset or another manufacturing piece of equipment, external sensors, auxiliary equipment, smart sensors that exist, such as these IO link sensors as well. There's a large array of those available today out on the market that can speak right away the digital language that then can facilitate that data transfer. And so that data transfer typically exists in the form of, as Julia mentioned earlier, machine state. Very simply, machine state, the state of the machine, and perhaps a basic part count. But it also can offer operational insights, such as what program am I running right now on this particular machine, and match and marry that up with the ERP system. That data is more and more, where modern platforms and gathering that information is becoming more effective for manufacturers due to labor challenges and simply eliminating waste from your plant floor. And that elimination of waste obviously is human and manual input. We're seeing that and a movement towards continuing that momentum and using smart systems and sensors and existing facilities today to be able to transfer that to those MES and ERP systems. So that's a little primer on what we're going to cover. On some of the capturing operational machine data. And I'm going to pass this next slide over to Colin. So Colin, take it away.
Yeah, thanks, John. So yeah, right, a good segue into that, right? We're talking about PLCs, more automated systems for data collection, because, data entry errors happen all the time. Operators have lots of other jobs and responsibilities that they're trying to get to. It's a waste of labor, right? So we want to rely on sensors, machine controls, and industrial protocols to get our data. But when it comes to making use of all this rich data we're collecting, right, there's a big barrier. When it comes to machine monitoring, I think it's kind of one of the fundamental things that have to be addressed before you get to things like getting it to your reporting, your MES, driving all those really cool, exciting value propositions, right? And that's standardizing the data, which is where a machine monitoring platform really excels. It's one of the main components, right? Something you'd expect. And if you've ever dabbled in maybe hooking up machines yourself, or you've looked at the different protocols out there, you'll see, and there's a lot of different protocols out there. And odds are you don't have the same machine and the same control across your entire facility. So how do you make sure that we're all talking the same language? When one machine says, it's active, it's being used, versus a different machine with a different control, that protocol might define active differently than the other one. So a machine monitoring solution that can map and kind of align this data across your equipment, so that as you get to those higher levels, right, you're looking at days and weeks, and you're looking at those kind of aggregated business metrics like OEE, your parts goal, your utilization. You're all speaking the same language, even between different facilities, right? If you have a multi-plant operation, people can be talking about different metrics that drive them, right? And it might be using some different language that needs to be aligned between different groups of people within a business. And machines are no different, right? They might all be speaking slightly different languages, communicating all the same underlying data, but communicating it in very different ways that would be extremely painful to parse out and understand on an individual basis. But when you can map and kind of aggregate that data, it lets you really start driving insights across all the machines instead of having to kind of treat every single machine as a unique special case. Yeah, go ahead. Thanks, John. So now I want to talk about how we actually make use of these. We're talking about connected factory, right? We're talking about connecting systems. How do those systems actually get connected? We've got our data standardized. Let's talk about how this actually happens. And a lot of jargon that gets thrown around, right, is, you'll probably hear them if you talk about connectivity and integrations between systems, is APIs and webhooks. So just want to set kind of a base level here because we're going to talk a little bit about them. I want to get to the exciting stuff and not get too technical with it. But I think it's important to understand kind of some of the data that's available here and how these tools can be utilized, especially when people are talking about connecting to a machine monitoring platform. What do they mean by APIs? And an API, in a simple term, right, is a way to interface between two software applications. And APIs can be either robust or weak, meaning an API that lets you communicate and do lots of things within a platform. You have lots of control. You can query the data you want to query. You can tell the system the data you need it to know. Or it can be a little lackluster where maybe it's really restrictive and you can only export certain things. I think you maybe lots of people experience this with maybe their ERP, where there's only very specific reports you can run instead of maybe being able to customize, or maybe you need additional help to be able to customize those reports. That's kind of the difference between a robust set of APIs versus something that's a little more restrictive. And then webhooks are a much more lightweight, and I think they're really exciting from a automation standpoint. You have a low code view where they let you basically, when something happens, they can trigger sending data to another system. So it's a lightweight API that powers one-way data sharing triggered by events. So something happens, you can fire a webhook, and that means sending data to another system. So it's a really nice kind of like cause and effect that you can easily integrate with lots of systems. There's lots of low and no code support for that. We're getting into that a little bit later, but now I want to go back to APIs and talk a little bit more in detail about the kind of data you can get from a machine monitoring platform, and maybe get your imagination going a little bit about how that can be used across the other factory systems. All right, so some of the standards you're going to be looking at, and now we're talking days, maybe you're talking hours here, right? You're looking back on a shift, but a lot of the time you're looking at maybe how your shifts ran over a week, or maybe even how you were doing over weeks or months of time, right? So historical production data. How are you doing? Are you really measuring up to your standards here? And with this kind of aggregated data, right, we've standardized the data, we've collected it, and now we can actually look at how we're doing across all of our machines from a much higher, kind of larger viewpoint for analyzing the historic data. It can be extremely powerful when paired with tools like you find within your ERP and the MES and those other functions. Whether it's improving just from things like improving your quoting, your availability, right? Recognizing those problems that John was identifying in the beginning, right? With lack of resourcing, over-resourcing, inventory problems, right? You can address a much more root cause starting at the machine when you have this level of data. And that does also factor in operational data, part numbers, operators, operations. And this all pairs to give you a much clearer vision than you otherwise would have of standard operation across your factory floor. And the last piece of data I want to jump into here is really kind of more on the technical side, the engineering side, is time series data. Now, this can be useful for a lot of different things, but there's some really amazing things you can do when you can monitor the data points on your machine kind of over time, right? And you can query it. You can in real time build custom applications on this data where you're able to stream exactly what's happening on a machine, whether it's the load, whether it's the exact execution state on a machine. This is I think just goes to show the power and flexibility that you can get when you're monitoring machines, and there's robust APIs that let you access kind of a wide variety of data to assess, to address a lot of different applications. All right, now I'm jumping back to webhooks. And so this is where I really wanted to spend a minute to talk to people about this kind of automation potential here. Because webhooks are really, if a system has webhooks, the machine monitoring platform has webhooks, or even some of your other systems, I highly recommend you take a look. Because there are a lot of tools out there, and people talk low code and things like that a lot, and they still oftentimes mean you're going to need to be pretty tech savvy to get this done. With webhooks, they're really taking it a step further, and there's been a lot of progress in this space from a technical perspective, where when an event happens, let's take a real life example, right? A machine alarm occurs, it's a critical alarm that's going to need maintenance's help. With webhooks, you could very easily send that data into another system using, the states right here, there's tools out there that have pre-existing connections between over 5,000 applications. Things like, Microsoft 365, so if that's Excel, you could do the Power BI, there's other databases like Microsoft SQL, and there are a ton of other tools, like I said, 5,000 plus. So odds are, one of those tools that you're using is going to factor into this. And that means without any engineering or technical assistance, you can drive action on the machine or an event occurring, like an alarm occurring, into actions in that other system, right? And so it's an extremely powerful way to kind of add automation to your to your business when you're connected to these machines. And I think even if you're not using them with machines, I think webhooks, they're extremely powerful way you can automate your business, and they just tie in extremely well with the data we're pulling off machines.
All right, thanks, Colin. We're going to jump right into our last piece here, and we have several good examples and also ample time to cover those. So I'm happy to hear or see that. And then, as mentioned before, any questions that you'd like to ask along the way, feel free to do so, and we'll do our best job of either answering those on the fly or at the end of the session here. So let's first talk about connecting, some use cases for connecting MES and ERP systems. And so for the sake of just this, connecting to MES and ERP, I have this icon. Basically, it encapsulates ERP, which is somewhat inclusive, let's say, of MES systems. So if we were to just assume that the MRP section right here is basically that MES type section in an ERP or separate, this will kind of tell the story. So the first example here is connecting into an MES or ERP system is basically the ability to start retrieving product information or part information. And so obviously you have a master data file that indicates what is my standard, let's say, cycle time, or what is my expected or standard parts per hour. This is where a machine monitoring platform can extract that from, that product master that lives in that ERP system. And in real time, and also after the fact, be able to present or measure against that particular standard of what you perhaps average per hour, what is your median per hour or median cycle time or average cycle time per hour versus that baseline. Well, that's one piece of it. You see on here, there's two arrows actually, extracting that information and contributing to that experience in live and real time. And then it's closed loop in the sense that the ability actually to pass that information back into either that product master or other systems. And that closing loop of that basically can contribute in a couple different ways. There's really many use cases, but we're going to focus in on kind of three core use cases here. And so when we gather that actual or average information from that machine, what we can do is first say, well, the CRM system, the quoting system, can very much benefit and be, or let's say, would benefit from this type of information. Obviously, many machine shops out there and other manufacturers have to quote this type of information out, and understanding true cycle times and how many units I'm making per hour is super important. The next piece of that is the manufacturing or MES system. A component of that is scheduling. So in scheduling, typically it's leveraging what's our expected rate. And it's giving you an understanding of when you expect to be completed. That transfers into capacity planning to realize how much load do I have in the next week, next month, how to prepare your resources in terms of bringing on additional people, maybe bringing on an additional shift, or maybe the inverse of that and taking, let's say, a shift away. That all has impact on those larger level business decisions that kind of permeate to the ERP system, right? And those longer term planning decisions. The last piece of this is from a financial side of things. In terms of costing your inventory, whether you're doing a job costing, where you're doing a one-off and you're doing, or a part that's maybe done once or twice a year. This is super valuable to you to be able to understand, am I making a good margin on this business? Do I want to tackle this job again? Is this going to help me? With just utilizing and leveraging theoretical and hypothetical information, you really don't have a true sense of what the actual cost may very well be. And the same is true for a standard cost. We want to, as close as possible in a larger production environment where we're leveraging standard costing models, we want to also be able to get as close as possible to what an actual is. And that's what that machine data is contributing to in the ERP, back into the ERP system. The other piece of this is not lost and is also important, is to be able to gather and collect setup time. So in the job shop world, this is potentially more of an offender than not running at rate, as an example, and can be very impactful to the business. So measuring that performance, not only on the part basis, but also on the human basis. So if you have operators that are, in today's world, there's high turnover, there's new skills that need to be attained. There's challenges inherently in that, and being able to expose that information out to be able to make those business decisions of, maybe I need training for Joe over here, or Bob can be a great mentor for Joe. Those types of decisions are super impactful as well. The next kind of really big use case and value add is facilitating that data transfer from that product, getting that into MachineMetrics and having that context. And we can do that kind of automatically in some cases, where we can actually kind of match up and marry up basically what's running on a, let's say a machine tool or a press as an example, where we can derive what that recipe or program is being run at that moment. So on a CNC program, there's oftentimes in the header, we're identifying key identifiers. That key identifier can be married up with that product. So we can autonomously collect that information without disrupting the operator and not even knowing, and also provide precision. The other piece of that is to be able to gather good parts from cycles right from that machine. And then also the element of either autonomously collecting the quality information or from a human. That closed loop process then goes back into that ERP system in the form of good or rejected or scrap parts. Huge value add in facilitating that transfer of data back into the ERP system and making it an afterthought and making it even easier for operators not to think about it. So Colin, take it away on BI.
Yeah, absolutely. So now we're talking about getting data into systems, right? And a big benefit, right, of connecting these systems, I think people always want to see, well, how can I see the data? And obviously MachineMetrics has lots of robust reporting in the app, but odds are your company standardizes on, or you have a preferred BI tool that you use. And so a lot of what we've seen is customers pulling data from machine monitoring platform, right, using those APIs that you can have like pre-built connectors and guides for to get you started with Power BI or Grafana, right? And using that data to drive your reporting as it exists today. You could have a report that you already are running, maybe manually compiling the data for, right, every week to send to supervisors or to show to higher ups, right? Or maybe you just want to have that report land on your desk every day and you're on the other side of things. You just want to be able to see the data and trust it. I know that it's real. I know that it's up to date. And this is where pulling in data from a machine monitoring platform into a BI tool can be so powerful, because it's going to be driven by actions people already taken, or like John said, we're already detecting the parts that are being made on the machine automatically. So we can tell you if a part is being made at, at the standards you're expecting it to be made at. You can look at your utilization across a wide range. And because we're cloud-based, right, with this, if you're doing multi-plant, right, if you have an on-prem solution, you're going to struggle to get data between those plants. There's going to be some hurdles there. But with a system like this, you can do just-in-time querying and query just for the data you need, no massive database, right? So instead of having a bunch of bloat for your, your BI information, your BI tools, you're able to query very selectively for what you need and answer the questions you basically need to answer. You have right then and there, right? No complicated digging for it. You can just go ahead and access the data, assuming it should be stored for, as long as you've collected it. You've got this robust, as soon as your machines are connected, you have this really robust history that you can trust to fall back on when making future decisions.
Okay, so I'm going to talk to you specifically about a use case around connecting to a CMMS or maintenance system. And so kind of getting down to, if we go back to that ISA 95 graphic, we're getting really down into that level 0, where we're connecting into potentially sensors. Those sensors could be, as mentioned before, could be internal sensors on, let's say, a machine itself. So we could be sensing, let's say, the load on a spindle is a great example of that. Or it could be auxiliary equipment. That auxiliary equipment could be, basically the coolant tank or the quality of the coolant. Those sensors that I mentioned before from the IO Link sensors, there's about 28,000 different types of sensors you can use to connect today, smart sensors, so to speak. Not limited to smart sensors, but it makes it easier to do that data transfer. Then in addition to that is an environmental sensors and conditions. So, really cool example of that is we have a customer that, they do paint and have paint lines as an example, and they have to abide by a certain standard. So the particulates and air are not violating the local EPA. And so by taking sensors kind of before and after that, let's say, filter, we can recognize, and manufacturers can recognize when, let's say, that filter is going bad. So you're taking action at the moment when it's needed, and it's not too late, and you're not burdening staff to, take the measures to check, the filter all the time, every day. And then lastly, avoiding huge impacts and fines. So that's kind of an example of, more of a environmental type condition or an HVAC situation where we can gather sensor information. And then what we can do is take that and do condition monitoring and threshold monitoring. So be able to take that, basically that condition and set a threshold on there where I was supposed to have a red line right here, but just imagine a red line that is actually breaching that, high or low, and then producing, alarm as a result of that. It's kind of like it's our logical alarm that's happened. It's not even coming from, let's say, the equipment itself, although that could be a source of an alarm. And then lastly, taking that and alerting the right people. And so that could come in the form of a maintenance team. Others could be informed, of course, but passing that into, let's say, a modern maintenance system. This just happens to be one of them, but there's a multitude of them, or a simple system that we have customers do, just like as Cullen is mentioning before, unlocking that information and saying, let's just pass it into an Excel spreadsheet. Something as simple as that, and be very effective still at solving the problem without a huge investment into another system, right? So this is a great example of connecting into a maintenance system. Another example that is hugely beneficial is starting to monitor machine cycles or hours, whether that's legacy equipment or modern equipment. So modern equipment, we're talking about PLC and CNC controls. We're talking about, for legacy equipment, sensors that can be put on, such as a current transducer over a motor lead or a spindle lead, and tapping into relays as inputs to measure cycles and measure basically hours accrued against a machine. And that then can pass into these modern maintenance systems that allow you to collect over time the cycles and the hours that then can be used to do basically meter-based PMs or usage-based PMs, and super effective at collecting that over time historically, and then making business decisions off of that, such as what is an appropriate time for me to change out the oil or change out the fluid, or be aware of potentially a catastrophic failure on a spindle, as an example. I'll go over to Cullen for this next slide.
Yeah, I'll round us out here. So, yeah, another form of communication. John hit on it, getting the information in front of the right person. So we're talking about kind of back to what you can do with no code here, and just webhooks with these examples here. But communication tools. How do you communicate internally? Maybe you don't have a dedicated communication tool. But I know a lot of our things that we've seen out there in use of manufacturers are things like Microsoft Teams or some other internal messaging tool are commonly used. And there's also other Kanban tools, kind of like Trello, one that lets you, visualize tasks and organize things. And using webhooks and kind of a connector, like there's tools like Make or Zapier out there, without any coding at all, you can have data pushing from either like that condition that John brought up. It could be an alarm, it could be poor performance on a machine, right? It could be a operator physically asking for help pressing a button that says, out of materials, need forklift, something along those lines. And this could work into your existing communication structure to alert the people in a kind of a channel that's easily monitored in a way that actually aids with communication and resolution of the problem, instead of these kind of issues remaining hidden or difficult to surface in time to make a difference. This can be real time. So you actually have time to get out and do something about it, right? And so by tying in the machine monitoring or these communication tools, that real-time aspect could just accelerate and really help to visualize and surface these issues in front of the right people.
All right. Well, we wanted to leave enough time for everybody to ask any questions, and let me go ahead, and I think we did have one question on here, didn't we, Cullen?
Yeah. Yes, thanks, Cullen and John. We're starting to get some questions in, but there's still time to submit one. You can do that using the Q&A tab at the right of your screen, and we'll do our best to get to it. But if we don't get to it today, someone can follow up with you via email. Okay, so first question. How long does it take for data collected from a machine to be available in the platform?
You want to?
I'll go ahead and
take that, or you take it?
No, I got it. Yeah, so it is a very short amount of time. Right? We're talking. You'll be able to see the difference if you're looking at a screen, right? And in MachineMetrics, when something starts, we're measuring in seconds, right? Now, if there's for historical reporting, right? There's also larger aggregated data that's going to be a little bit more behind real time, but for real-time data, right? Like you're looking at it, when that machine goes on, you'll be able to see it very quickly. That the light, basically the Kanban of our system, turn green when the machine starts. So seconds.
Okay, next question. How difficult is it to connect a machine, and what does that process look like?
Yeah, I can take that one.
I'll leave that one to you, John. Yeah.
Thanks. Great question. Yeah, so typically, just to answer it directly, it depends, of course, but it really depends on the whether or not that machine is, let's say, has a legacy control on it, or a modern control, or no control at all. And so with a modern control, typically with let's say a FANUC or a Haas, in the machine tool space, or a Wintris, let's say, in a press space, or an Allen Bradley or Siemens PLC, that event can take typically anywhere from a minute to maybe an hour to connect to that and start pulling data off of it. So that's typically the time frame. And in a legacy, let's say, equipment connection, that means that you install some additional sensors, and typically that you can estimate about an hour, maybe an hour and a half, to typically get rich data such as basic machine utilization and part counting. And that really, just going back to it, is really dependent on the adapters that can speak to that equipment. And so that edge or IIoT device, that gateway that can speak to that, that's basically those drivers that are running on that, let's say, that device that can then negotiate and speak that, kind of do a plug and play experience actually, where that can get up and live as soon as possible. Very good question.
All right. What are some common systems webhooks you can connect to?
Right. Yeah, I'll go ahead and take this one. So we covered a couple, but I would highly recommend, if you want the full list, like I said, 5,000 plus, some of the common ones are systems like even just something like Google Sheets is extremely powerful and ties right into things like Zapier or Make that you can have free tiers, so you can get this full automation without paying for any additional software. And using tools like that, I mean, if you go to their website, they have lists of thousands of different applications they connect to. So really, the sky is the absolute limit. Obviously, older on-prem systems might be harder to connect to, but there's still a huge variety of systems like this. Like there was a graph there, and I mentioned earlier, Excel and 365, even some of the more standard core Office applications have ways to connect to these kind of cloud-based systems and interact with webhooks.
All right. Can you identify the start of a setup with machine data only, the goal being to automate the start of the setup in the ERP or MES without operator clock-in?
Yeah, that's a super good question. And the answer to that is yes. We can identify the start of that setup with machine data only. And in fact, MachineMetrics is, we are in the process of perfecting basically those that data capture of that and triggering basically that setup time. So it's done with predictive and algorithmic functions today, and using historical information, and then over time learning that particular machine, whether it's a machine tool or it's a let's say another type of piece of equipment, and then basically being able to identify key events, which include stoppages, alarms, and then also maybe jogging of the machine in the case of a machine tool. That presents a unique pattern that is then measured against what is in reality. So the answer to that question is yes. That is a capability.
Yeah, I want to follow up real quick there too, John, that like you said, we can also detect kind of with that setup, right? We can also get the part number, right? An operation that's going on for that given span of time as well, even from the control information, right, from the program. And so sort of the goal, your question here said with the goal is automating the MES or ERP, right? Combining these different pieces with, if your ERP has capability of like dynamic allocation, right? To decide where these parts should go based on the schedule or just that dynamic allocation functionality, you can get an extremely automated process with very minimal operator input, right? Where this data is kind of automatically flowing between systems that know what to do with it.
All right. Let's see. Do you have a standard way of integrating?
Yeah. So I think depending on this question, you could say like integrating different systems or integrating our machines. And
yeah, if the person who sent that in wants to send in like a follow-up clarification, feel free to do that. But otherwise, you can interpret that as you will.
Yeah, we can touch on both real quick. So with integration, it does, if we're talking software integration, we do have open APIs, and they're available. You can take a look at them. MachineMetrics, developers, MachineMetrics.com. Developers.machinemetrics.com. And standard way of integrating, we have some out-of-the-box integrations. We do have webhooks available as well. Those are some of our go-to recommendations for integrations. And so I'd say that it does depend on the system, and there are standards like we set into those. We socket into that system that has 5,000 other applications. But if you have something custom, right, or a legacy piece of equipment, I recommend taking a look at our APIs. And our recommendation is to make use of those open APIs we have and some of the public guides that we have to kind of guide you through getting started with them. Looks like you just moved your screen, John. And if I was just going to follow up real quick to say, if that was more around standard for integrating machines, then the question is, it does vary by basically the protocol that the machine is communicating, right? If it's legacy, it might be sensors installed. If it's FANUC focus control, we can tie directly to it, right? And generally, it's just a matter of networking that machine, and then we can connect to it. It depends on the protocol, so there are slightly different steps. But overall, we do kind of have standards for each of those and how we tackle each different protocol and different type of machine control that's out there.
Okay, I have one more question here. So if anybody has anything else they want to ask, make sure to get it in as soon as possible. But for right now, our last question is, what is the maximum synchronous polling rate?
Yeah, I don't know if you want this one, John. I'm happy to take it. And so that sounds good. So again, I'll address this from both ends, whether we're talking about whether we're communicating to the machine, right? So our communication, how rapidly we're collecting data, as well as how rapidly you could pull our APIs. How quickly could you ask us for data, or how repeatedly? So generally with our integrations, the standard is 1 Hertz. So that's kind of our rate of polling for most of our integrations. That does vary by situation a little bit, but that's the baseline. Maximum, that does depend on the control and the data provided. There are sensors that can handle a lot more, and there are also controls that do not output that much. But certainly what we call higher frequency data, up to 500 Hertz, is certainly something that we've worked with before. But generally, we're talking numbers that data scientists care about in those terms, and obviously that can be used for those applications. But you sort of move into the world of data science, right, and a little bit more of that granular analysis of the data at that level of frequency. And for our APIs, we also have there's not a particular polling rate. I think generally based on the question, tags pulled per second, I think you probably mean the machine connection. But for our APIs, generally check the normal rate limiting, but we also have the ability to subscribe to data points. So as soon as a data point is updated in our system, we just send you the new value. So sort of no need to do a very rapid polling of our APIs, given how we have them currently set up.
Yeah, just want to add to that really quick. In some use cases as well, as Colin has mentioned, the high frequency data capture, depending on the control, we've had connection where we can go basically down to 1/4000. So down to a quarter millisecond type level, and sometimes higher, for getting tool monitoring type of information from, let's say, a FANUC control as an example.
All right, I think that's all we have for today. I want to thank Cullen, John, and MachineMetrics for making this webinar possible, and thank you to everyone for listening in. You should receive an email with a link to the recording soon. Thank you for your time, and enjoy the rest of your day.
Have a good one, everyone.